All right, so in 910, then, they finally kind of make the connection that, oh, I mean, I've already said this today, but e to the x is a famous function, and he has a famous power series. It is this. And you can prove that this converges for all x, and it converges to e to the x, I guess. We talked like this a few minutes ago, earlier today. But in 9.10, it's like, there's one, on my take-home assignments, I refer to page 670. There's a little chart in 910 where they give you these famous series. There's famous ones. Page 670, they give you all these famous power series. They don't really write them like I just did. Here's sine x. They do sine x. Can anybody read it to me? What do they write? They write x minus x cubed over 3 factorial. Is that what they do?
Yeah.
X to the 5th over, see, I guess I got it memorized, sort of. Minus x to the 7th over 7 factorial. So they write that. Later on, do they give you an nth term? What do they write later on? Do they write x to the 2n plus 1 over 2n plus 1 factorial?
And then they do a negative 1 to the n.
And a negative 1 to the n. So they're calling that the nth term. You know, this is the first term, the second term, the third term. Here's the nth term. If you were trying to write it in what I might call closed form, summation notation, then what would you write? You'd write your nth term, wouldn't you? Wouldn't you write? So guess what that is? Sine x. Cosine x is similar. Cosine x, though, starts at 1, and then it's the even powers. X squared over 2 factorial, x to the 4th over 4 factorial, blah, 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 blah. By the time, if you want to write it in summation, closed summation notation, what is cosine x? It's right there. Negative 1 to the n, x to the 2n, 2n, negative 1, n, x to 2n, 2n, factorial. Check this out, you guys. I mean, these things are so beautiful. Listen. What's the derivative of sine? Cosine? Okay, watch this. What's the derivative of sine? Ready? Watch this. What's the derivative of him? What's the derivative of him? You bring the 3 down. It cancels with that 3, leaving you, I mean, that's a 3 factorial, which is 3 times 2 times 1. So when the 3 comes down and cancels with the 3, you're left with 2 factorial, x squared over 2 factorial. Let's take this derivative. You bring the 5 down, it cancels with the 5 from the 5 factorial, leaving you 4 factorial with x to the 4th on top. The derivative of sine is cosine.
Right.
The derivative of this polynomial is this polynomial. Dude, what's the derivative of e to the x? Himself? Hang on, let me check this out. This starts with a 1 plus x squared over 2 plus x cubed over 6 plus x to the 4th over 24. I mean, that's what this is, right? That's 2 factorial, 3 factorial, 4 factorial. I just filled that in for you. Anyway, let's take his derivative. The derivative of him is himself. Check it out. What's the derivative of the 1? Nothing. What's the derivative of this? 1. What's the derivative of this? That's an x. What's the derivative of this? You bring the 3 down, cancels with the 6, leaves you x squared over 2.
2.
The derivative of him is himself. What I ask you to do, and what I think I want you to, once you get to 910, you don't have to build these things from scratch anymore. Once you're in 910, you use the given knowledge that's given. And I only wrote these 3 down. There's about 6 or 7 of these written there. There's log x, and there's tangent, arctangent, I mean, there's a few other ones. But here's what I want to say. Using 9.10, can you find a series for 3x squared e to the negative 2x? Now in 9.7, how would you do that? In 9.7, you'd say, oh shit, I got to do 4 or 5 derivatives, build a Taylor polynomial, see if I can see a pattern, then I'll have a series maybe. But using 9.10, you get to use what's already been built. So you get to use this. Now, if this is e to the x, how do you get e to the negative 2x? The word is replace. If this is e to the x, e to the negative 2x is replace all the x's with negative 2x. Replace all the x's with negative 2x. So you get 1 plus negative 2x plus negative 2x squared over 2 plus negative 2x cubed over 3 factorial, 6. You guys following me? We just built e to the negative 2x from e to the x by replacing the x's with negative 2x. It's so easy. Oh wait, though, I want this. So I want to take, what do I want to do now? Multiply 3x squared times my polynomial. Okay. So 3x squared e to the negative 2x is 3x squared times this, 3x squared times this. I mean, I guess 3x squared times this. At some point, I need to do some simplifying. Are you with me? And when I do some simplifying, I will no longer see the pattern maybe too well. But I replaced negative 2x for the x, and then I multiplied everybody by 3x squared. And then I could work on simplifying it. It's so easy. Up in 9.10, you get to use given information to help you. You know what I could have done? Watch this, watch this, watch this, watch this. I wonder if I could have done it with this. If I want 3x squared e to the negative 2x, watch this. What's the first thing I did? Replace all the x's with negative 2x. So I could replace that x with negative 2x to the n over n factorial. So now I got e to the negative 2x, dude. Infinite notation. Now I want to multiply by 3x squared. I think I could just, what did I do with the 3x squared? Didn't I just multiply it by every term? Yeah. Well, then I think to multiply, I can just multiply it by every term. This is it. We just built ourselves an infinite series that matches this. We built them using this. Easy. I mean, I did it the easy way. I'm up in 9.10. I'm allowed to use given knowledge to build new things. It's easy. Here's my favorite one. You ready for this? I want to do e to the 2x times the sine of 4x. Can you build one for e to the 2x? Let's build one for e to the 2x. And by the way, I don't want this to be infinite. I think I want a 5th degree polynomial. 5th degree polynomial. That's what I want. Let's see. Can you build one for e to the 2x? How do you do e to the x? Oh, that's easy. There's e to the x. And how do I get e to the 2x? Replace all the x's with a 2x. Shit, that's nothing to that. That's a 2x. That's a 2x squared over 2. That's a 2x cubed over 6. That's a 2x to the 4th over 24. Blah, blah, blah. Maybe I need 2x to the 5th. I'm going off camera now. 2x to the 5th over 120, right? I'm going to stop there. How do I get a sine of 4x? How do I get a sine of 4x? Do I have something called the sine of x? Yes. There's sine of x. How do you get sine of 4x? Replace all the x's with a 4x. Don't forget they're in parentheses though. You know, so it is 4x, and then it's minus 4x cubed over 3 factorial, and then it's plus 4x to the 5th over 5 factorial. Are you guys with me?
Yes, in
I'm
parentheses.
looking at the sign formula here, replacing all the x's with a 4x. Hey, I'm not going to go to the 7th. Remember what the question was? Come up with a 5th degree polynomial for this. What should I do now? I've got e to the 2x, I've got sine 4x, and I'm trying to multiply them. So how do I multiply? What should I do now? I'm trying to multiply them. What should I do? Everybody's favorite thing to do when you multiply stuff. Foil! Major foiling action. Listen, here's some weird thing some student might think. Stop. Watch this. The weird thing that's wrong. The wrong weird thing that you might think. I don't mean you're weird, but you might say, well, you multiply them, then multiply this, multiply this, multiply those, multiply those, multiply those. But you don't multiply corresponding terms. You know that if this is multiplied by this, then it's like this infinite parenthesis thing multiplied by this infinite parenthesis thing. And you know how to do that. You have to multiply everybody times everybody. It's infinite foiling, except it's not infinite, because remember I said I want to stop at a 5th degree. So I'm not, you think I'm weird. I'm not that weird. I don't really want to do infinite foiling. I mean, I like math. But can you stop at a 5th degree? Probably. Check this out. Can you do the 1 times him? Good job. Can you do the 1 times him? Good job, good job, good job. That's 64x cubed over 6. Can you do the 1 times him? Yeah, I guess so. That's 4 to the 5th, x to the 5th, 5 factorial. Watch this. Can you do the 2x times him? 8x squared. Can you do the 2x times him? Oh, by the way, that was him. Wasn't it? 2x times him. It's 2x times 64x cubed over 6. You guys okay? Are you guys okay? 2x times him. Here we go. 2x times him. Anybody want to do that? You know what? That'll give me a 6th degree term. I don't need that. Remember? I wanted a 5th degree? I don't need that 6th degree term. Are you following me? So everybody who's moaning and groaning needs to take it back. This ain't as bad as you thought. This ain't, you're trying to get to a 5th degree, you take your moans and groans back. This is not bad. I mean, I described it as bad. I said it's infinite foiling. But really, if I'm only one a 5th degree, it ain't going to be as bad as you think, but there's more to it. What about this? This thing times the 4x, right?
Right.
This thing times him. That'll be a 5th degree.
That'll be a 50, and then you stop.
Okay, then I'll stop with him. What about this? This is a 3rd degree. This, you know what? It might help if these things were simplified a little bit before you started multiplying them. Maybe I'd simplify them first and then multiply them. But this 3rd degree times him. What about this 3rd degree times this 3rd degree? I wouldn't even bother.
No.
That's a 6th degree. I don't need it if the question wants a 5th degree. Cool. What about this 4th degree? 4th degree times him. Yeah, I'll need that. What about this 5th degree? Oh, I don't even need this. I don't even need this.
You stop. Okay.
And then I'll combine like terms and I'll have a 5th degree polynomial that matches this using 9.10. The same problem using 9.7 would be what? Take 5 derivatives and build a polynomial. I'd rather not. Using 9.10, I'm allowed to use given series and multiply them together. All right, so I just did, I think, a pretty good lecture on 9.7 through 9.10. And I mean, connecting thoughts. And it's really the important thoughts. I mean, I didn't take you anywhere I didn't want to take you. There's a lot of stuff. I mean, the book explores this a little further than I wanted to. I don't have time to. But we did good. So this video would help. But you got a lot of work to do before Friday. You got that first take-home quiz is kind of hard. It's got 16 questions, and I'm only going to randomly grade 4. Is that what it says?
Yeah.